Okay, simple harmonic motion. First topic in this new topic set. This is now going to be where we're going to extend now from looking at different motion that is now oscillating to try to figure out what's going on this. And it built right into what we're going to go into next, which is all of our wave motion. So here we go, simple harmonic motion. Maybe. Got some technical difficulties going on this morning, so I'm trying to make this video. Here we go. Okay. So yesterday we saw, or I should say this morning we saw a kind of simple pendulum. Okay, and a pendulum is nothing more than a weight that's hanging on a string. It's kind of one of these things that swings back and forth. Now, why is this considered harmonic? Okay. Harmonic means that it's a repeated motion. It started to get a pattern. We sometimes call this a periodic motion, like a repeated pattern, like the periodic table. And if we look at it, it's there because of the weight of the pendulum bob. So in other words, if I have my free body diagram, okay, here's my free body diagram. Okay, I've got my weight acting down, and I've got my tension acting this way. So there's my two forces that are on my pendulum bob. Well, a component of my weight is actually what's equal to my tension force, and then the other component of my weight is actually what's causing the motion to go. So in other words, that's my force times my acceleration. Now that acceleration is going to be proportional then to part of gravity. So in other words, it's a lot like a free fall problem in which the pendulum is falling towards the ground, but it's following that kind of curve. It's kind of like rolling down an incline, okay? Very much like the first things that we did in class. So that's what makes this whole thing kind of a periodic motion or a harmonic motion. Now, typically what happens is this pendulum wants to swing over to here and wants to swing back, and it would keep swinging as long as there wasn't any other forces acting upon it. But we do have other forces like a friction force. That's the air molecules that are in the air that kind of dampen the motion. Okay, so we usually see somewhat of a dampening motion, and eventually it'll stop. Now, what would happen if we took a pendulum up into the moon, let's say? Well, the moon doesn't have any atmosphere, okay? And if you don't have any atmosphere, that pendulum would be allowed to go because there wouldn't be any air resistance against it, and so we would see that pendulum going forever, okay? And so that's where we're kind of looking at it. If we can reduce the friction, we can keep that motion going, okay? Because the amount of energy that we get is equal to the amount of energy that we get out of it. And that's, by the way, another way to look at these pendulums is to look at them from an energy standpoint. If we pull a pendulum back at that very top here, at that maximum displacement, we have all potential energy. Okay, so we have a gravitational potential energy. It then swings forward and it loses some of its potential energy. It turns it into kinetic energy. So we're always looking at it from different standpoints of either energy, or we can look at it from the standpoint of forces. Okay, so there's different ways to look at these pendulums, but all of them mean that we are going to see this harmonic motion or this oscillating or this periodic motion. So those are all different ways to kind of talk about it. Now, when we are studying these pendulums, we're going to have a couple of different things that we're going to need to know, okay, and three specific vocabulary terms. Now, two of them we've already kind of talked about before, and that's period and the frequency. And I got a nice picture here of a grandfather clock, and the grandfather clock has a pendulum in it right there, and that pendulum is what actually keeps the time. So in other words, there's a time relationship to that pendulum swing, and we call that the period. Okay, the period is the amount of time per cycle. Okay, it's the time per cycle. So in other words, we have a relationship that we like to talk about, and we know that there's a time related to it, and so that's where we see this as our period. So the period is related now to the kind of, and you see this L is the length, Okay, so in other words, this would be my length of my pendulum. Gravity, okay, makes sense. It's a relationship between these two. There's a relationship between them. It's the square root of it. And you see that, and that 2 pi starts to tell you that we're looking at kind of an arc length motion, so we're looking at a part of a circle motion. And so that's where we're seeing this tie into our circular motion as well. So now this is our relationship that tells us about the period of any given pendulum. So in other words, if you know those things, you can solve for the period or the time that it takes to make one cycle. Now the frequency is nothing more than the number of cycles per given is 1 over the period, or the period is 1 over the frequency. Okay, so that's how we kind of relate those two. Now, so those two are related. What about this amplitude thing? Well, the amplitude deals with how much energy we gave it. Okay, so this is an energy.